Hello, everyone. Welcome to another ACE Spotlight event. My name is Alireza Darbehani, and I will be your host today and the discussion facilitator. Before I get into introducing our great speaker today, I would like to make some announcements. Tomorrow noon, we will have another spotlight event about a literature review on ML in climate science. And tomorrow evening, we would have another live event about a data set for fine-grained video action understanding and our experience with building a high-quality data set. I would like to make two more announcements. We have two great workshops coming up. Today is the last day for signing up for the GAN workshops. It's called GAN from Theory to Deployment. It's a really great workshop, and if you need like a discount code, you can reach out to one of the steering committee members at ACE. Also, on June 8th, we would have another NLP workshop starting. It's called NLP from Theory to Deployment. And again, if you want to access a discount code, just reach out to one of the steering committee members. So I would like to introduce our speaker today, Yochay. Yochay is an experienced tech leader who has been named in the 2020 Forbes 30 under 30 for achievements in AI advancement and for building Converge.io. Since the age of 7, Yochay has been writing code. After 3 years of consulting for companies in the AI and ML space, Yochay, along with his co-founder, decided to create a tool to help data scientists and companies scale their AI and machine learning projects. So without further ado, Yochay, please take us away.
Thank you very much, Ali. Thanks for the opportunity to speak here. It's very exciting for us, for me. So I'm happy to start talking about MLOps and the different challenges that we solve also as part of our company and the different use cases that we help companies. All right, so today we're going to discuss about how to solve different MLOps challenges. We'll also start with what is exactly MLOps is and what are the common challenges that companies are facing. Before we get started, a quick introduction of myself. Like Ali said, I'm a developer, turned into a CEO. We started Converge as data scientists. We did data science for other companies in NLP and speech recognition and deep learning and a lot of other stuff. And during that time, we saw that we need a platform to help us manage and organize our data science workflows, our models, experiments, research, production. And we also noticed that we spend a lot of our time on stuff that don't really relate to data science, like DevOps and IT. So we decided to build Converge. And Converge was an internal product that we used. It was extremely helpful for us. We saw it can help other companies as well. So we decided to take it out to production and build a company out of it. And this is what we've been doing over the past few years. So we started, Converge because data scientists are spending 65% of their time on DevOps. And also 85% of the models don't get to production. And this is happening because a lot of different challenges. This is a paper published by Google a few years ago. It's describing the hidden technical debt in machine learning systems. What happened when a company is trying to get from prototyping mode to production? So suddenly they face a lot of different challenges around resource management, which is a big problem that also Kubernetes is aimed to solve, serving infrastructure, configuration, data verification, data collection, monitoring of models, both in training and also in production, and a lot of stuff, and very little room there for the actual magic, like the stuff that really gives us the competitive advantage, the cool stuff, the algorithms, and this is just growing. When you take models to production, also not only the data scientists are in charge of the process, also IT. IT are responsible of managing critical infrastructure or managing production workloads, managing software in production, and recently also models in production. Data scientists, it's the second different persona. They're focused on building algorithm, doing statistic, math, computer science stuff. They're focused on generating insights from data. And those two different paths, the fact that it's evolving two different paths is making it even harder for enterprises and companies to get to production. In fact, like the numbers before, 85% of the models don't get to production. When you take a look at the machine learning development map, so it involves two different pipelines, two different workflows. The first one is the MLOps side, so DevOps, like development has their own operations, so machine learning also has its own, and it includes configurations, installation, scheduling of experiments, of machine learning training and machine learning scoring. It also involves visualization of models in production and also in training. It involves lifecycle and integration to different IT ecosystem tools like Git and Docker and containers and Kubernetes and Spark and other IT managed solutions. It also requires collaboration between the different personas in the data science workflow and monitoring. The entire process has to be monitored. Machine learning is hard to manage. It's not only about like building the algorithm. You need to, a lot of the time, need to retrain the model. So tracking and monitoring this kind of pipeline is hard. On the right side, we have the data science workflow. It's the common use flow of having data selection, data preparation, model research. That part also needs to be versioned a lot of the times. You run experiments, you run different model training, you do some validation, you tune the model again, then you deploy, and then you continuously need to monitor deployment and perhaps even retrain the model in order to keep it fresh. This entire pipeline also needs to be tracked. Like, imagine a world where, let's say I have 50 models in production, and I want to go back 3 months ago to see exactly why my model predicted that customer Y is predicted as users that might churn, or even for quality assurance, for testing, or for regulations and stuff like that. I would need to be able to track and trace any prediction to any model and any data that it was created with. So each step here has to be versioned. It might be hard to do, but it's very important, especially when you get to production, and especially if the IT is now managing the production use case. This complexity is basically the main reason of why models are not being deployed to production. They're staying at the data science space. They are not effective. Data scientists are extremely expensive, as we all know. So having both the fact that data scientists are spending a lot of their time on non-data science, and also when they do produce models, they don't get to production because of this kind of problems. That's a big pain. That's a big waste on the enterprise level, and for the data science team as well. What we do at Converge, we solve that. We aim to solve that. Converge is one of the leading MLOps platforms in the world. And we help teams to manage MLOps from init to deployment to management of the entire pipeline. And also we provide a suite for the entire data science workflow, for data preparation, for data selection, model training, tracking of models, and deploy models to production. Converge also is code first. It's full stack, it's container based, and it's also native to work with Kubernetes. It accelerates data science from research to production and can work on any cloud. Converge, we are not only data scientists, we're also engineers, or what's called today machine learning engineers. So Converge, the platform, can be installed anywhere, and then you can attach different compute resources to the platform. So we're working also closely with on-prem compute companies like NVIDIA GPUs, Dell storage companies, cloud resources as well. We sort of like create one place for the entire machine learning compute. You can attach laptops, you can attach on-prem compute, on-prem HPC, you can also attach cloud resources and have all the compute nodes available as a pool for running machine learning workloads. You can run training, you can run data preparation, deploying models, workspace, and a lot of other tools as well. We'll now go through some of the use cases that Converge can work with, and then we'll just dive into a technical hands-on demo. Sorry. So this pipeline, Converge has this tool called Flows. Flows enables data scientists to build production pipelines. You can build those pipelines with the UI, or you can build those through code, through YAML configuration files. In this case, I'm loading data, and then I'm training a model using the PyTorch framework. I'm also training a model using the Keras framework, and those models are competing with each other. Who has the best accuracy? And then the best model is being compressed and shipped to production. This pipeline runs continuously, so it runs every day, every week, whenever I have new data available for model training. Converge also is great for version controlling data. So like with the example we talked about before, we want to be able to allow data scientists or data science team or the IT to know exactly for every model that they built, exactly what kind of algorithm they were using to train that kind of model, what kind of code version, what were the hyperparameters, and also what was the data that was used to train the model in the specific version. In this case, you can see data coming in from Postgres. Of course, you can use any kind of database. The output is automatically fed to a pre-processing component written in Python. And also, it's being versioned in the backend. So if I need to trace, if I need to trace back, I'll be able to see that this is specific version. Then after the pre-processing, I'm going to train 3 different models. I'm going to train SVM, XGBoost, and gradient boosting by scikit-learn. And I'm going to have, for each of those different components, I'm going to have like grid search, like hyperparameter optimization. Meaning that so far we built like a data versioning pipeline and also my own custom AutoML. I'm testing a lot of different algorithms at scale, running on Kubernetes, cloud, or on-prem. And then the last part, I want to deploy to production. But before that, I want to also to use best practices of software development. I want to create a pull request on GitHub with the winning model. So let's say XGBoost was the best model that was created. The next component in the pipeline will create a pull request in my GitHub repository or GitLab, and and we'll post the statistic of the training to the pull request. Then once the pull request is being merged, it can trigger the actual deployment pipeline.
Yochay, I have a question here. So
Sure.
for these components on your pipeline, are they like just like pre-coded components, or do developer can go in and modify some code and customize it a little bit?
Right. So that's a great question. And it's actually, we have a lot of pre-built machine learning components, but our platform, it is code first. Like our users are usually expert data scientists, expert data engineers, machine learning engineers, that a lot of the time want to create their own machine learning components. So through each component here can be either you can build your own or use the pre-built.
Got you. Thank you.
Sure. Next is a nice pipeline of a Kubernetes recommendation engine. So in this case, I'm loading data from multiple sources. Let's say I'm having the data on S3 on AWS, but I have also the data from BigQuery, and then I'm running a pre-processing step with Spark. So the two data sets, two data queries will be merged to this component. And then the output of the pre-processing step will automatically move to a TensorFlow ranking algorithm and also XGBoost. And again, it's very similar to this, where I build my own custom AutoML. So in this recommendation engine, I'm doing the same. I want to pick always the best model for the right data, for the specific data, and have the right model in production. Sometimes my model tomorrow might work better with TensorFlow ranking, or the next day it can use XGBoost. So in the platform, in this pipeline, we support this kind of variation. And this is important to keep your models the best performing for the job. Next, the best model is automatically being deployed as a Kubernetes API. All right, let's go to a demo. Okay. So this is the Converge platform. Here you can see all the different projects we're currently working on. Converge in terms of UI, you can think of it sort of like Git designed for data science. It makes the entire data science workflow accessible, reproducible, organized, and managed. You can finally share models, share research, share experiments, and have everyone on the same page. We also have Converge Python SDK, a CLI, and a REST API, so it can be very easily support other workflows, also CI/CD with Git or something like that. It's extremely flexible. Besides those projects right here, we also have a lot of example projects, which makes the onboarding to Converge very easy. All right, before we jump into one of the projects, I want to show you compute. So the way Converge is architected is that you can install the platform anywhere. It can be installed on a VM, it can be installed on AWS or on-prem. And then you can attach different compute resources to the platform. So let's say you have a GPU on-prem server, or you have your AWS Kubernetes cluster, anything can be connected to here. And then you have like one centralized environment for all the machine learning compute resources. You can also create your own EC2 instances list. So let's say you want your data scientists need large CPU template or GPU templates, then you can create them all right here. And you can very easily add new compute templates to the platform.
So one question here. Well, from the audience, someone asked, did you say that the version control is based on Git? Earlier, when you were explaining the pipeline.
Right. So Converge, each project, each pipeline can be integrated to Git. So you can version control with Git, or you can use the internal tool that we have in Converge for versioning. For data, we built our own data version control tool that supports large amount of files and large files as well. And this is something that Git is currently lacking. So we had to build our own.
Cool. Also, I myself have a question. So let's say you want to use AWS or Google Cloud Platform, and you mentioned it's easy to integrate with those. How does this happen? Is it like you just give the credentials to the API of those cloud providers, and your platform actually communicates with their API to create resources or remove resources, right? Is that
Exactly.
it?
Yeah. Yeah. So there are actually multiple ways to integrate with different cloud vendors. You can just integrate your credentials, and then Converge will use those credentials to spin up resources in your cloud. Or there is also another way that if you have, let's say, EKS, like an Elastic Kubernetes service by Amazon, you can just plug in your Kubernetes cluster from Amazon, paste the kube config right here, and you're good to go. This means that you can manage your own clusters and simply connect them to the platform. This saves a lot of time and also provide you with like flexibility to control your own compute resources.
Gotcha.
Now, next part is containers. So Converge is container based. We have a lot of pre-built containers as part of the product, but it's extremely easy to add your own. You can attach different registries. You can pull containers from remote registries as well with this simple UI. And we also announced a couple of months ago, we announced a partnership with NVIDIA that all of NVIDIA deep learning, machine learning containers are available in Converge. This is really cool because eventually you have direct access to TensorFlow running built by the NVIDIA data science team. All right, last part before we go into a specific project is data. So you can attach, you can use any data source you want to connect with the platform. And the nice thing about Converge is that it's versioning your data. So any change that you're making in the data is automatically captured, just like Git. You can version the data and spread it across different commits. So that's extremely useful also when you have a lot of data. Okay, we'll now jump into one of the projects. We'll use MNIST as an example to show you how you build and deploy a model with Converge. So like I said, we have a CLI, we have a Python SDK that can be used to run machine learning workloads on your compute resources with very simple command. But we also have the UI, and the UI allows you to spin up any kind of workspace you want, whether it's Jupyter Lab, Jupyter Notebooks, also VS Code, for example. I can now choose a compute resource that I want, whether it's on-prem or in the cloud. And I can also choose a Docker container. So let's say I want to use the TensorFlow by NVIDIA container. And I can also choose a data set. Now, what's unique about this compute is that this is designed for hybrid cloud environments. So it has something that we call like a queuing system that this is my DGX1 running on-prem, but let's say I want to use my cloud as a fallback. So I simply choose the AWS Spot instance, P2 extra large. And this means that once I start a workspace, Converge will spin up resource on my DGX on-prem compute. And if it's full, if it's in full capacity, if it reached like 100% utilization, it will automatically scale up to the cloud, burst to the cloud. So this means that we help a lot of companies to reach to 100% utilization of all their on-prem compute and then burst to the cloud only when they really need it. Now, once I hit start, Converge will spin up a resource in the cloud or on-prem. It will install dependencies, install my code, my container, all of the thing I need to start building my model. And I now have a working VS Code on a remote server in just one click. And this is really awesome for data scientists for the day-to-day work. It saves a lot of time and make our work much more productive. I can also attach data sets on the fly. I can use the AI library that I showed before just as code. So let's say I want to use the CSV pre-processing step. I can just copy this code and use it right here.
Cool. I have a question. You mentioned the queuing on the platform. So does that mean that like if let's say we have 10 data scientists, they can share resources and schedule their work when it comes to using those cluster or on-prem resources?
Yeah, this is exactly the use case, and this is also we partner uh, very well with companies like NVIDIA or Dell, is because we allow you to manage compute resources for machine learning across your team. You don't need to fight who's using the GPU, who's using the CPU cluster. Everything can be managed from the UI. You have full control. You can see, you can prioritize jobs and have everything pre-configured.
Right. One follow-up question.
Sure.
So yeah, I kind of forgot what I was gonna say, but somebody asked like, why using Kubernetes for training? Isn't it for more high availability versus when we do training, we need the high performance, having the maximum amount of resources. Also, my question, it came back to me. So for queuing, is there any like how do you prioritize? Is it like first come first served, or some user can get a privilege to use more resources?
Yeah, so the admin of the platform can manage who's getting what kind of resources and who has access to what compute templates. And if they're using the same compute template, then it's it's a first serve.
Cool. And also the question related to using Kubernetes clusters for training. How would we meet the goal of having highest performance instead of highest availability?
Yeah. So Kubernetes is a great tool for orchestrating containers on compute. There are a lot of different use cases. You can use Kubernetes for multi-node distributed training. You can use it for classic machine learning. Basically, there is no change in performance. There shouldn't be change in performance when you run it on Kubernetes. It just runs your container on the remote cluster, and it's supporting like a lot of production use cases like distributed training and Spark on Kubernetes is becoming like a really good thing, and also others.
Thanks.
Cool. All right. Next up is the experiments page. So machine learning experiments is something that happens a lot when you train a model. So a lot of the time you have data, you have an idea for an algorithms, and you want to just test it. And you might test it a few hundred times. In this project, I have 126 different experiments. Each experiment here represents some sort of like a command, a Python script, an R script, any kind of programming language, and basically tracks everything. So our story of Converge, going back to some history, we started from this. We wanted a place where we can manage and track everything that we do in a data science project. It's extremely important for the research phase and also very important for production. So each experiment here is basically a model that we train with different hyperparameters, different compute, different Git version, and stuff like that. And Converge automatically tracks the entire run. So this is the script that I ran before, and Converge tracks when did it start, when did it end, start commit, end commit, CPU, memory. It also tracks hyperparameters and metrics. It can also plot line charts and heat maps and stuff like that. And you can see all the output of the experiment right here in real time. And if a file was created while this experiment was running, then you will be able to see it right here. And this is really cool because this means that you get sort of like with the same workflow that you have of running Python script or running R script, you get like a database of all the different models that you built with exactly how they were trained, with what kind of data, metrics, hyperparameters, everything is automatically being captured. And you can even select a few experiments, you can run, compare, and then see all the experiments side by side with exactly what happened in each model.
So
Right.
for this monitoring purposes, so for example, let's say I create a new project from scratch and I do custom coding. Like let's say I use either TensorFlow or PyTorch to train a model. And like, do I need to export this type of numbers to monitor the performance and the overall parameters of the model, or is it automatically picked up by your platform?
Right. So that's a great question. So first of all, we have native integration to like frameworks like TensorFlow, Keras, PyTorch, scikit-learn, and we automatically capture loss and accuracy and validation accuracy and stuff like that. It's being picked up automatically from the output log. And we support 2 additional methods to create custom metrics. So a lot of the time, the data scientists have their own metrics they want to track. So to track your metrics, the only thing you need to do is just print to the output converge tag, a key, and a value. Just print to the output, and this will be automatically picked up as a tag, and that you can visualize and see in the UI. The other way is with our Python SDK. So we actually have a very nice Python SDK. This is our documentation page, where you can track different models with the 2 lines of code. And you can create heat maps, and you can even animate heat maps, and you can have bar charts and stuff like that. So it's very nice, great way to track the different models. Okay, so after you have all the experiments and you're ready to go to production, we have flows. So our vision with Converge is to bridge in the gap between science and engineering. So data scientists run their models, they run tracking, they want to do hyperparameter optimization, and then they get stuck when they need to move it to production. So for that, we have flows. Flows is like an interactive tool that you can design machine learning pipelines. Those could be like the question before, could be designed through the UI, or it can also be designed through a YAML code. Each flow here can be represented by a YAML code that can be imported, exported, and you can also store it at Git or something like that. Now, those components right here, this graph is running as a DAG. So each component is running on its turn. In our case, this is the data, the MNIST PNG files. Then I'm doing some pre-processing. In this case, I'm using Spark to run some pre-processing. This is the Python command, and this is running on my DGX1 with the, let's say, the Convert Spark Docker container. Each component here, as you may see, can run on different compute with different container. This means that you can have a single pipeline running on a lot of different compute resources. So this is running on my on-prem Spark cluster. This can run on a GPU on AWS. This can run on a GPU on-prem, and this can run on a CPU on AWS. Each of those components can also have multiple compute templates like we did before, so it can do like a queuing system. Now, what's going to happen here is that I'm going to pre-process the data. The output will be automatically sent to those 3 different models, and those models will be fighting each other who has the best accuracy, who is the top performing model. And then the best model will be automatically picked up. The champion model will be picked up and be deployed as a web service on Kubernetes. This could be a web service, it could be batch prediction, and it can also support streaming endpoint. Now, this model will be running. I can also do hyperparameter optimization in each of those components. So once I run it, it's going to run 9 experiments. And when I run it, all the experiments will be automatically tracked in the experiments tab. Now, the last part is about deploying the best model as a web service. So what we do is we allow scientists and data engineers to expose their models as web APIs. We completely automate the deployment part of the model. So you don't need to worry about HTTP serving or Kafka streaming or batch prediction stuff. You can just deploy your models from the UI. And besides the fact that we automated this DevOps work, we also provide with like an X-ray to the model. You can see all the input and all the output of the model. Everything is being tracked, just like you have model repository. This is also tracking the predictions. So you know that this model prediction was this is the input variables, and this is the model that was used to predict this function. We also have Kibana and Grafana and Prometheus open source tools built in on the cluster. So you can build dashboards, you can visualize your logs and stuff like that. And let's say you have a new model that needs to be deployed to the same endpoint. So you just click new version, and you can do some A/B testing, and you can choose let's say the model that I trained. So let's say experiment 207 was the best experiment. So I can just click update and it's good to go. Then the last part is about monitoring models in production. So let's say I have today 5 models in production. I have a team of 5 data scientists. Management saw that data science is providing very good ROI. Churn prediction models are working great. Or my computer vision model is saving a lot of money to the company. Then they decided to scale the data science team. This means that you have in very short period of time, you can get to a point that you have like 50 models in production. And monitoring 50 models in production can be very hard. So what we do is we allow you to create alerts on your models, and then Converge will continuously monitor your models in production. So let's say I have a specific model, and I want to detect that if, let's say, the data that is fed to the model in production is not correlated to the training data, then this might be bad. It might be a sign that maybe I need to retrain the model or get new data and then train the model. Or let's say I want to track the model confidence. So here with this UI, you can track any kind of parameter that you want. It's going to also work with our Python SDK. So I can track, let's say, data correlation. And then I want to track that if the data correlation is below 0.5 for every prediction, or for, let's say, in 10 minutes, there are like 5 events, 5 predictions that this is happening, then automatically email the data scientist. Or you can even take it one step further, retrain the model, get the latest data from S3 and rerun the training pipeline. So whenever my model in production drops below, the data correlation drops below 0.5, it will automatically run the pipeline that we had set up before. And this is really nice because then I have like CI/CD, continuous integration, continuous deployment, or what we call continuous training and continuous deployment for all my models in production, where I know exactly how they were trained, with what data, what algorithm, what hyperparameters, and also how they behave in production, which is very important as well. So you get like one place to manage all the models, and from training and research to actual deployment models in production. Yeah. So besides that, in Converge, we also have the apps where we allow data scientists to just deploy dashboards. It could be R Shiny, it could be Dash, it could be Jupyter, voila. We also have the AI library, which is a repository of machine learning components that you get like an easy start. XGBoost, scikit-learn models are just ready to use. Um, and um, and we also have recently we released Converge Core, which is a free platform, a free machine learning platform that can be deployed on any Kubernetes server, any Kubernetes cluster, which is just like a single command, and you can just start and use Converge today. Yeah, this is basically it. I can go over a few more functionalities of the product, but maybe we can leave some room for more questions.
Sounds good. Yeah, I already have a couple of questions ready. One of the audience asked, like, can different users share artifacts, for example, the pipelines?
Yeah. So each organization in Converge can have multiple users with different access roles. So you can have manager, you can have data scientist, you can have read-only access. Um, and then each project in Converge, you can have different users. So let's say in my MNIST project, those users have access to see the product, to see the project. And you can also customize it, and you can limit access, and you can also integrate that project to Git and other nice stuff.
Great. Another question is about, it's great that we can use it on a hybrid, on-prem cloud or even local, machine. So the question is, can we have finer management on that? For example, can we put a condition to trigger cloud instances on certain circumstances?
Yes. Yeah, so that's a great question. So in the compute resources, in the compute tab, you can attach all the different compute resources, whether it's cloud or on-prem, and then have like one place to track all the different, to manage all the machine learning compute. And for cloud bursting, we currently support the queuing system that I showed before, that you can attach multiple compute templates to each job that you run. This can also be configured on the organization level. So you can have the default that each job, all the jobs will start running on-prem and then only scale to the cloud when you get to 100% utilization. And this is the control level. We're planning also to enhance that and add some more rule-based cloud bursting. But yeah, this is what we have now.
Sounds good. And another, it's more of a business question. So in terms of functionality, it's very similar to some other options existing. For example, Data IQ and Rapid Miner. So what is the strength of your platform that makes user to use it?
Right. So yeah, it's a good question, and the Data IQ and RapidMiner are a great platform for data scientists. Our focus with Converge is to provide a code-first platform. Like we expect our data scientists to write code, to write Python, to write R, any kind of programming language they want. But that's a requirement to use Converge. Also, Converge is based on software development best practices, container-based, hybrid cloud, Kubernetes. All those kind of tools are first citizens of the product. But yeah, the main difference is the fact that we are a code-first platform.
Awesome. So if there is no question, if there is any, just please post it in the chat. If not, we can go off, end the live streaming shortly. Let's wait. Okay. Okay. The question is the platform. I'm not sure if I understand it correctly, but it says the platform only runs on their servers. What is their on your servers? That's I don't think that's the case, but the question is basically your own server, like the Converge servers, and what is the privacy policy for that?
Yeah. So Converge platform is a product that is installed in the customer environment. We have a trial environment, but all of our customer will eventually install Converge in their own private environment, whether it's AWS or on-prem. And the license agreement includes the privacy and the terms of use, but data is not living. Don't see your data. We don't have any access to your data because the platform is installed in your private environment.
Awesome. So I don't think there is any other question. Well, thank you very much, all the audience, for your time to attend our spotlight today. As I announced earlier, please check out our featured talks as well as the workshops, upcoming workshops. And thank you so much, Yochay, for a great presentation. My recommendation to everyone would be to go and try out the community version, like install it and play around it and see if it can be helpful for your project. If there is nothing else, we can, I guess, close the live streaming.
Yeah, I would just want to say thank you, Ali, for hosting me, for the great opportunity, and also thanks everyone for the great questions and fun. So I hope to see you again soon.
Great. Have a great day, everyone.
Thanks. Bye-bye.
Yeah, I